Okay, so in this video we will see the support vector machine, means how the support vector machine algorithm work, that we will see. And when we talk about the support vector machine algorithm, that is the one machine learning algorithm, right? And means it is used for what, as we know, it is used for supervised machine learning, right? And in supervised machine learning there is the two things that we already discussed in the video one. There is the classification and the second one is the regression. Okay. So first we will see how it works in the classification, then also we try to solve some classification related real problem with the help of the Python. Okay. So now if we talk about the only classification, okay, then suppose this is the one problem their salary is given, age is given, and customer will buy our service or will not buy our service. So that prediction I want to do with the machine, and I will check the support vector machine how perform, okay, on this particular data set. So if I quickly plot the one graph, now you can see, just assume that I just try to plot this means whatever the data, salary and age. Okay, so just assume that in the means this is the one variable salary, okay, and here one variable, that is the age. Okay, and I just plot the scatter plot diagram, and now I try to solve this particular problem with the, just assume that logistic regression. Then logistic regression, what it will do, it will just draw the one line, that line able to classify both category yes and no. Okay, so this is the one line, and this line will classify, okay, a particular means point belong to which class. And sometime maybe here the data is like that, so we can easily implement the logistic regression because this line able to classify the data, right? So now the next point is we can solve this problem with the logistic regression. Okay, and how it mathematically work, that also I will show you quickly. 1 minute. So here you can see I'm just trying to make the line, and that line we can convert into the mathematical equation, right? So every line means in mathematical equation we can convert. Okay, so this is the mathematical representation of this line. So this line may be classified both the data set. Okay, so that's the point. Okay, in this line, in this direction may be no, all customer means that is belong to the no, means they will not buy our services, and in this side I'm assuming yes. Okay, so that classification is maybe possible with the help of the logistic regression. So we will check that, okay, means what will be the accuracy after applying the logistic regression, right? So if you want to see, okay, how it's work, suppose I will write the equation, and if I say just show me the greater than this area, right, and what is the less than to this particular line. Okay, so if I just want to see the less than this particular area, so anything will come in this area, means in this you can say the green area, that is belong to the what, that you can say that is belong to the no, and this belong to the yes. So that's the way to classify the customer, means if we want to do the classification, then logistic regression how classify, that I just try to represent here. Okay, so now, okay, so here you can see anything if we are above than this, then it will consider yes, means they will buy the services, below then they will not buy services. And that all the thing how, first I plot the scatter graph, then I will see that I able to plot the line or not. That is just assumption that this data is like that. Okay, I'm not plotting this data actually, but I'm just assuming to explain the algorithm, right? So now this is about the logistic regression. Now what the support vector machine say, support vector machine say maybe this equation in the logistic regression is like that, then also it will give the good accuracy. Okay, but suppose just assume that I'm passing the some test data, and that test data is actually belongs to the node, and this line actually classify, and this line, if I use the logistic regression, in that case this line will tell that this belong to the yes category. Okay, so it say means it will give the wrong prediction, and it will say the customer will buy our services, right? So this is not in that case the best fit line. So how to draw the best fit line? So there is the one is the best fit line or best fit plane to classify the data. So there is this one support vector, means machine, that algorithm suggests some different things. So now that we will discuss. Here you can see what it will help us, means it will say the support vector classifier, there the suggestion, this is the best fit line in the blue color. So that is nothing but you can say the hyperplane. Okay, hyperplane, in the means machine learning it's known as a hyperplane, and that is the best fit line. With the help of that actually we will do the prediction, and this two line is nothing but the marginal plane. Okay, and this support vector. So this means in the orange line actually is, you can say, the marginal plane. Now what the support vector classifier do? It will try to draw the means the distance of the marginal plane from the hyperplane is always equal. Okay, so that one criteria you need to remember in this algorithm. The next, it will try to maximize the distance between these two hyperplanes, so we will get the best fit line. So that I will show, suppose here, and now again this algorithm will check quickly. Okay, so like that it will check where I'm getting the maximum distance, and now maybe here means this line is getting the maximum distance, the distance between the marginal plane, this two yellow is more, so that is the best fit line. And these are the support vector. Okay, so actually supporting the marginal plane, so that's why these are the support vector. And this algorithm is known as means this algorithm is known as a support vector classifier. I will show you the some quickly some animated thing, so it will really give you the some idea. Okay, so now you can see here, means if I quickly copy, now you can see how means machine actually maximize the distance between the marginal plane. Okay, and if the machine get the maximum distance, means then it will assume okay, that line is the best fit line. So like that it will identify the means it will try to maximize the distance between the marginal plane. So there are other also, so that also I quickly show the some other animation. Now you can see machine try to see means where I'm getting the maximum distance between this marginal plane, so I will get the means this best hyperplane, or you can say the best fit line. So this is the way, and that is more you can say the precise compared to the previous logistic regression. Okay, so this will give the good result obviously when we compare with you can say with the logistic regression. Okay, so now again I can show you the some more, like here you can see the machine try to maximize the distance between the two hyperplane, and these are the support vector who actually support, okay, to make the maximize the distance. Okay, so this is about the support vector.